All right, let's talk threads in 5 minutes. A thread is a separate flow of execution within the same executable, the same process. So, for example, you could have main doing one thing and some other part of your program doing another thing at the same time in parallel with each other. This is very useful if you're going to be doing things like blocking for input. So, for example, if you're making World of Warcraft, it'd really suck if every time somebody had to type in some words, the entire game would freeze, which is what happens right now if you do a CN. If you do a CN, it pauses and it will not progress the program any further until you type something in, and that'd be really kind of lame. So here I've made a type racer type of game. See, the time is running, but everything appears to be paused. Once I hit return, now you can see the time is updated. There's 3.6 seconds left. Type in bench, and now we're done. So you see that this game is not very good because I kind of want to have a timer that's kind of sitting there spinning and timing down, but in a single threaded program, you can't really do that. So let's take a look at the code that we have right now. Single threaded code. I got some globals. Globals are bad, but we'll get more into that next time. So I've got here a main, and main loads the English dictionary here into a vector, and then gets the current time like that using chrono. And every time the user types in something, it checks to see if it matches the current word. If it is, the score gets incremented. It then picks a different random word from a vector. This is a iterator pointing at the beginning of the vector, and then it randomly picks another thing, and it just kind of moves the iterator around, and it picks a random word every time. I didn't seed the random number generator, so we get the same random numbers every time, if you were noticing that. If they get the wrong word, then it pauses for a half second. Use sleep, microsleep allows you to sleep for a number of microseconds. So 500,000 microseconds is half a second. And it just kind of does this. But here's the blocking part right here. So when you do a read, it stops the entire thread. The whole thing stops and just waits for input. Kind of sucks because we want that timer moving. So I refactored this as a multi-threaded program. So same code. Basically, I think I moved where I'm doing the timings around a little bit. It doesn't really matter. So I have this print score function. The print score prints the current score, the current word, the time remaining, same as the other code. One difference here is that this is a while true loop because it's just going to sit there over and over again, printing the current score, printing the time remaining 5 times per second or 50 times per second. It'll update, and it'll just do that until there's no time left. And so that's kind of why I moved the timer code into there. It's going to sit there and recalculate how much time is remaining over and over again. Once it hits 0, the thread ends. Now, basically the same code as before. How hard is it to actually do multi-threading in C++? The answer is it's not very hard. Hashtag include thread. There you go. Here's how we do it. Rather than me calling the function from main, which means it's going to not get called that often because, remember, this is going to pause the program. Instead, I do this. So I create a thread. I make a variable name for the thread, and the variable name is USA. Just because, I don't know, I'm terrible at variable names. And I was kind of joking online that all my variable names from now on are going to be called USA instead of Bob, in honor of Amerigo Vespucci, where we name everything after a random Italian map maker, because nobody had a better name for it. So, USA it is. And this here is the function to be called. So, what it's going to do, it's going to run this function, print score, in a different thread. And so, when we get to this point here, it is going to spawn the thread, and it goes off and it will do its own thing, and it'll update over and over again. And then we just do our thing, and we can sit here and pause and wait as long as we want, and the screen will keep updating because this function up here is running in its own thread. And it's literally that easy. There's only one trick to this that is a giant sharp edge that can cut you. So it's really simple, right? Make a thread named USA. Name doesn't matter, really. And that's the function to run. And that function will go ahead and do its own thing. That function can call other functions. It's fine. It's like a second main almost. Now, the thing is, you either have to do one of these two things. You either have to detach the function, which means it'll just go off and do its own thing. And if you want to just like almost have a second program running, you can do that. That's a perfectly valid option. Just let it run, finish whenever, we don't care. But if you want to know in main when the thread finishes, then you don't detach it. And down here, you use join. And so basically when main gets to this part of code down here, it'll wait for the thread to finish. And that's very useful if you're going to be synchronizing lots of threads running at the same time. For example, it's very common to spawn off a different thread, like if you're processing a large array or something like that. Right? You might chop the array up into 10 or 20 pieces or something and give one thread to each one. And then you need to wait until all the threads are done before you can move on with your thing. And so what you do is you for loop, spawn off 10, 20 threads, whatever. And then you for loop after you've spawned them all off, then you for loop join all of them. And so that will wait one at a time for them to come back and say, I'm done, I'm done, I'm done, I'm done, I'm done. And then you move on with your life and you take the computation, whatever it was you're computing. Maybe you do it again, like if you're averaging an array or something like that. Then you need to know when a thread finishes so you can synchronize. Synchronizing is one of the hardest things in parallel processing. But for this assignment, we don't care because the timer will just quit when it runs out of time, and we're going to quit when we run out of time, so good to go. Okay, so we'll just detach it. So we're going to spawn thread USA. It's going to run that function up there, and it'll just do its own thing, and while we're sitting here waiting for the user to type in the word, it's doing its thing. It's updating the time remaining and that kind of stuff. There is one trick though, one final trick, and that is you have to compile the code with -pthread. -pthread enables multi-threading on Linux systems, or GNU plus Linux as I've taken to calling it these days. So here we go, and you can see right here the timer is running, and I got one right, pinch. That's an unfortunate word, but whatever, typos, here's so on and so forth. And so the thing, if I wanted to do this for realsies, no, 80 WPM, not too bad, not too bad. Okay, so yeah, so there you go. So you can have the one thing in the background that's updating the screen, and then main down here is waiting for input. Or you could do it the other way around. You could have the thing that's handling input be spawned off in its own thread, and whenever the user gets around to typing the thing, they get around to typing the thing, and the rest of the program is just doing its happy business in the meantime. So same program as before, just that function, rather than being called over and over again in this while loop, we spawned it off here, and it had its own while loop that has basically the same check. Like, while there's time remaining, keep going. It's basically the same thing as this, right? So both threads are basically just watching, hey, is there any time remaining? If there is, they keep going. If not, they kill themselves. Now, there is one final wrinkle with the main here, which is that it actually won't end this loop while it's blocked, right? It'll just sit there and block, and so you could feasibly get off like one extra word, right? So in order to stop that, because it's kind of lame, right, to give them overtime, on a word speed test, what I did was I set up an alarm. And so an alarm tells the Unix operating system, whatever flavor you're using, it says, hey, in 10 seconds, duration is a constant, that's how long we're running our typing test for, 10 seconds. Hey, in 10 seconds, send a SIG alarm to me. That's what alarm means. And you can think of signals as kind of like interrupts in C++, where you throw an interrupt and then you have to catch it, and if you don't catch it, it kills your program. That's how it works for most of these signals in Unix. If it throws a SIG alarm at you and you don't catch it, it kills your program. All right, so if I run this real fast, it won't be real fast, it'll take 10 seconds. What will happen is the default SIG alarm handler will run, which will print alarm clock and kill the program. And it kind of looks a little lame to me to print alarm clock and kill the program. And so what I did was I wrote my own signal handler so that when I get a SIG alarm, then we're going to do a callback here. And this is a function pointer. I'm passing a function to it. The function's name is alarm boy. Notice I don't have the parentheses here as if I was calling it. Nope, I am passing the function itself to the callback. And so that says in 10 seconds, all this together means in 10 seconds, run alarm boy. Okay? And alarm boy clears the screen, kind of cleans everything up, moves the cursor to row 2, column 0, prints times up, prints your final score, and quits the program. Okay? So that is just a way of interrupting us from getting a little extra overtime here on this. Otherwise, this would block kind of forever. If we wanted to structure the program differently, we could have spawned off 2 threads, one for updating the screen, one for taking the input, and then main itself could just like when time's up, it just prints the score and quits, and then the threads just would go away or something. But you can always structure these things in different ways. Anyway, so yeah, the move cursor function is part of my colors library. You can find that online. That moves the cursor to a certain spot on the screen. Clear screen is also part of that. It clears the screen. I think that's the only... Oh, and read is part of my read lib. Is this a wrapper around CN. So this here will read a string. So that's all you really need to know about that. Not too much. Anyway, that's threads. It's actually really easy. Step 1, make a thread, give it a variable name, give it a function to run, and that function starts running. And then you can either just detach it and just like let it do its own thing, or you can, if you care, you can wait for it, and then after it returns, then you can clear the screen and print the score that way. That's it. See you guys next time.